Ladies and gentlemen, a very good afternoon to you. First and foremost, many thanks for joining us today for what I hope will prove to be an informative discussion regarding both the practical and the technical aspects of the IMO's Tier III requirements for NOx emissions. My name is Julian Smith and I'm Principal Surveyor at the Cayman Islands Shipping Registry, a member of the Red Ensign Group and one of the world's leading yacht registries, which offers a wide range of ownership structures and a solid political, legal and fiscal operating environment. Today's panel is made up of a broad cross-section of industry stakeholders, which includes a naval architect, key component suppliers for selective catalytic reduction systems, system integrators and operators. So without any further delay, I will ask my fellow members to introduce themselves.
Hello everyone, my name is Mar Tobias and I'm the co-owner and creative director of Diana Yacht Design. Diana is an independent design office based in Holland and we are specialized in design, naval architecture and engineering of superyachts. The company was founded almost 50 years ago and from that day over 70 yachts were built at 22 shipyards worldwide based on our drawings. And today I'm here to tell you a little bit more about the challenges we are facing when implementing the new IMO Tier III regulations in the design.
Yes, good afternoon, everyone. My name is Romain Guilbault, and I am the Technical Superintendent at Fraser Yachts. Fraser Yachts is a world-leading company specialized in superyacht chartering, brokerage, management, and new build or large refit project management. Our main strength at Fraser lays within our expert team and its great network, who is able to deliver its clients with the highest quality of service in full transparency. Maintaining our connection with the IMO and the industry is a priority for us, and we are therefore very, very pleased to be here today and share with you our experience on the IMO Tier III.
Good afternoon, everyone. I really appreciate being part of this panel. My name is Dennis Bravenboer. I am International Sales Manager and Superyacht Segment Specialist at Hook Engineering. For over 35 years, Hook Engineering is the leading after-treatment specialist in a wide range of markets with their headquarters in Elso, Switzerland. The heart of the Maritime and Yachting Division is in the Netherlands. Today, I will walk you through some technical aspects of the equipment to be able to apply to IMO Tier III regulations.
Hello, good afternoon. My name is Jeroen van der Matte. I'm the General Manager Operations at Markup. Markup is a well-known exhaust system integrator. We are always looking for the best possible solution in your engine room. By looking to the total picture, we can give you the benefits.
Excellent. Thanks, guys. Okay, gentlemen. So as we all know, the environmental impact of yachting and indeed the maritime industry as a whole is a hot topic at present, and quite rightly so. The IMO has now presented its roadmap with a view to reducing greenhouse gas emissions by 50% when compared with the levels that we produced in 2008. Calculation procedures for the energy efficiency design index for yachts are currently under discussion, as is the ongoing regulatory requirements for ships' energy efficiency management plans. And in support of these developments, the collection of fuel oil consumption data is now mandatory since March 2018. For vessels of greater than 5,000 gross tons. On the 1st of January this year, we've seen the implementation of the global sulfur cap outside of the designated ECAs of 0.5% mass by mass, a reduction of 3% on previous limitations, which has had a major impact on merchant shipping, albeit yachts operating on marine distillate fuels haven't been affected. So firstly, Dennis, could you tell us something about why it is we must comply with IMO Tier III and in which regions, please?
Yes, absolutely. IMO Tier III regulations are applicable for all marine diesel engines with a power output over 130 kilowatt installed on a ship constructed on or after January 1st, 2016, bigger than 500 DT, operating in emission-controlled areas. Starting January 1st, 2021, these same regulations will apply for all seagoing vessels below 500 DT. For vessels in fleet, IMO Tier III regulations will apply when a major engine conversion is taking place. When a diesel engine above 130 kilowatts is replaced by a non-identical one, this engine needs to apply to IMO Tier III regulations. There are some exemptions in general when a vessel does not have to apply. These exemptions, they are for vessels below 24 meters, designed and used only for recreational purposes, yachts without yacht charter class, so recreational use only, constructed before January 1st, 2021, and a vessel with combined installed engine power below 750 kilowatts that cannot comply due to construction limitations. That are the rules.
Great, thanks, Dennis. Let me just share my screen a moment. Okay. So here we can see a map of the world illustrating both the current emission control area in North America and the Caribbean, which affects vessels, the keels of which were laid on or after the 1st of January 2016. Here it's worth noting that the North American ECA extends up to 200 nautical miles off the shores of the US. Now, all ships operating in this region are subject to examination under port state control while operating in US waters, and either the Coast Guard or the Environmental Protection Agency may bring an enforcement action against a ship owner in the event of a violation. Near the middle of the image, we can see the area shown in blue, which is the North and Baltic Seas. This area is already a SOx seeker for sulfur emissions and will also constitute a NOx seeker for those vessels, the keels of which are laid on or after the 1st of January next year. And with respect to future ECAs that regulate NOx emissions, the Tier 3 standards will apply to those ships whose keels are laid on or after the date of adoption of such an ECA. So Dennis, perhaps you could tell us something about how selective catalytic reduction works, please.
Yes, absolutely. Allow me to share my screen. Here you can see the principle of a chemical reduction of the selective catalytic reduction. This is a means of converting nitrogen oxides with the use of a catalyst into diatomic nitrogen and water. When you add urea and oxygen to the toxic nitrogen monoxide and let them through a catalyst, a chemical process will take place, resulting in a non-toxic nitrogen and water. These are the basic principles of a SCR system.
Thanks, Dennis. So what is it we consider to constitute the main difficulties while designing IMO Tier III compliant vessels in general? What I've noticed from our side as a regulator is that NOx certification is a combined certification process and must have one responsible applicant. Now that applicant is subsequently responsible for obtaining the required certification for the combined engine and after treatment system, regardless of how many manufacturers are involved, and in almost all cases ends up being the shipyard. This process subsequently exposes the builder to significant liabilities in the event that the completed system is found to be non-compliant once installed. Design and installation considerations from the regulator's perspective are relatively straightforward. Tanks may be either freestanding or integral, and corrosion protection is critical, noting the caustic nature of the urea. Such tanks may be located in the engine room or other enclosed spaces, but forced ventilation systems should provide at least 6 air changes per hour and be provided with low flow alarms on the extraction side. Temperature and level monitoring is to be provided, and vent pipes should terminate in a safe location. Piping is not to be routed through accommodation spaces and service spaces, and basic PPE for crews should be provided, including coveralls, gloves, eye wash stations, and safety showers. Moving forwards, the greatest concerns appear to be in the sub-500 GT market, where compact solutions are quite clearly required, particularly in light of the recent decisions taken by the IMO with respect to vessels above 24 meters in this size range.
Yeah, maybe I can also comment on that. And as Dennis explained, the new units, they need urea. So first of all, you need to store it, and as you already told a little bit about it, it's important to consider that early in the design stage. If integrated into the double bottom, the tank needs to be made out of stainless steel. Alternatively, you could also use a PE tank, which is more complex maybe. The tank needs to be equipped with sensors so that the temperature of the urea can be controlled. If it gets too warm, it will degrade prematurely. And also the important thing is that you have to take in consideration that urea is a caustic liquid. And then the next part of the system is the SCR unit itself. It's quite large, using a lot of the already limited engine room space on most boats. And additionally, some units require a silencer to be installed for sound reductions, using even more space. And luckily, some manufacturers integrate the silencer and the unit in one system. Others design the unit which, in such a way that it fits above the silencer between the deck. But for the unit to work properly, it needs a minimal size so the gases can mix and the urea can do its job.
IMO Tier III systems are a balanced act between available space, required maximum back pressure, sound, vibration, issues, materials, and strength. Buying only loose components might give you problems in the future when completing the total exhaust because of a lack of back pressure left for the underwater exhaust. Good contact with system integrators like Markup and naval architects could prevent those issues in the future.
Yeah, I agree with you. We need to work together to build experience. This is a new system. Nobody has a good database yet. So it's important to get the suppliers involved as soon as possible. Together with the naval architect and the yard, and the system can be optimized to make sure it does what it's supposed to do.
Yes, absolutely. We need to work together for that. And optimization is achieved by combining efficient technologies. For that, we need cooperation between multiple specialists, like you said, like Markup and the panel of experts who I'm lucky to discuss with today. And if we want to select the most efficient and reliable solution, that cooperation must start from the very first stages of a project. This is also a role as end users to share our experience with you guys so it can be used to improve existing systems. If we install a combination of efficient green technology on board of new yachts, like electric propulsion, energy storage systems, solar panels, latest glass technology to reduce the heat load and the AC consumption, and etc., we can increase the overall efficiency, reducing therefore the generator size, and we can fit the exhaust after treatment system, like the SCRs, much more easily.
Romain, we spoke about refits of ships, and with repowering, they need to comply with IMO Tier III as well. What challenges do ship owners face in these refits?
Yeah, it's true that refits is a real challenge for owners. At the moment, all Tier III conversion projects I was involved with, or that I heard of, have been cancelled when the existing engine could be kept. When the engine were damaged or no longer fit for purpose and had to be replaced, we've always been able to get a dispensation under MEPC 230. So a Tier II engine was fitted instead. Of course, replacement of exhaust and optimization of the space generate an important cost, but I don't think this is the main reason why Tier III conversion projects are not performed. More than any other reason, I think that the physical space required on board is the main limiting factor. Hans Martin, you probably got involved also with a refit project as naval architect. What is your opinion about that?
My opinion is that space is the limiting factor. In general, these ships, they fit together like a puzzle. And now we're adding a new unit. So we're installing an SCR unit, and you need to fit a urea tank somewhere. As explained before, this tanks to start with has to be out of stainless steel, which is no problem if you integrate it right from the start. But adding it later, it can be an issue, as most of the time it's part of the bottom construction. So it's a big change. And the SCR unit needs space and cooling in the engine room. And for large yachts with enough height, a place can be found. But for smaller yachts, and I think especially on fast production boats, I can imagine that it will be a lot more challenging. Another downside maybe is that the SCR is also an additional point of failure, and it could potentially put an end to a charter or to an owner's trip. Indeed, some systems, they suffer from reliability issues, which become a big problem, especially on setups where the engine can't run independently from the SCR. And Dennis, can you explain something to the viewers, what happens if a system runs out of urea?
Yes, of course. The majority of SCR specialists use airflow as cooling. This means the SCR system is able to run safely without urea. I cannot speak for other SCR providers, but the HUX system will go in alarm, running without urea as a warning signal. As said, it does not shut down, but it will go in alarm as a notification towards the crew. For the minority of SCR unit manufacturers who are using urea as cooling for the unit, I guess everybody can imagine what will happen when you run without urea. In addition to what I just said, all equipment works together like a chain, and we need each other to make things work. For example, it is important for the SCR specialist to receive the latest version of the emission data sheets and the technical files from an engine manufacturer. With these files, the SCR specialist can add the engine to its engine family certificate. For new generation engines, it's very important that the engine manufacturer provides information about the engine family this new engine is going to belong to. Last part of this part is that it also seems that engine rooms are filling up with equipment more and more. Therefore, it can be an advantage to combine dominant pieces of equipment like SCR DPF or an SCR and silencer. The demand of smart and compact solutions in which you combine several techniques into one unit is increasing, and I'm really looking forward to see what Markup is foreseeing.
Yes, thank you, Dennis. What we are seeing is that we are going to integrate systems together. So SCR, DPF silencers, SCR DPFs. What you can see here is a semi-displacement 28 meters with 2 times 1500 kilowatt engines propulsion with an SCR silencer with integrated cooling. So everything fits in one unit to save as much space as we can. The box is approximately 2300 millimeter long, 1400 millimeters in wide, and 680 millimeters high. This is relatively small, and in our opinion, we can optimize this system within the same footprint as the original silencer.
Yes, thank you, Jeroen. I think that this is very encouraging. The system that you are showing is for a 28-meter vessel, so you're getting very close to providing a very good solution for such yachts and small vessels. So such innovation will definitely make conversion easier in the future. We feel that it is our role as management company to listen to super-yacht owner representative, crew, technical directors, and managers to report back what challenge they are facing. And this is what we do. That way we can guide innovation towards appropriate solutions like combined exhaust components or smaller Urea storage space. Clearly, such solution will enable owners to approve the replacement of their old dirty engine for brand new clean systems. However, this is still impossible due to, if this is still impossible, sorry, due to physical constraints on board that are too restrictive. We can also apply for dispensation to flag. Julian, can you explain what is behind MEPC 230?
Yeah, certainly. I think at the Cayman Islands Shipping Register, we've dealt with several yachts which are replacing main and auxiliary machinery and have been unable to source Tier III engines which meet the required specifications and could be accommodated within the existing space and weight restrictions. So in such cases, an exemption request has been submitted in accordance with the provisions of MEPC 230/65. The process requires a documented search for Tier III compliant machinery options and the provision of a robust technical justification with respect to why compliant machinery cannot be installed on the grounds that it simply isn't feasible. For a limited number of cases, we have accepted that it is not possible and granted a formal exemption in order to allow the owners to replace their existing machinery with Tier II compliant engines. It's important to note that the acceptance criteria contained within such circulars is likely to change as and when compact solutions become more and more available. As far as the US is concerned, the Environmental Protection Agency currently accept this approach, although they have indicated that their position may change. So it's important to obtain the most up-to-date advice from them prior to proceeding in such a manner.
And do we have any experience in the existing and coming regulations already? And do we know, maybe Romain, any vessels that already comply to IMO Tier III?
Yes, it's true that we are only now starting to see IMO Tier III compliant yachts coming out of the shipyards. Currently, out of the 95 yachts that Fraser have under management and the dozen new build projects, 5 are IMO Tier III compliant today. So this is a very new system for all of us, but we start to receive very valuable feedback from the crew on how this system operates. Clearly, the proportion of IMO Tier III yacht is going to increase a lot in the next years. And that is why Fraser is actively collecting experience and sharing it with, within the company, the rest of the fleet, but also is willing to do with the rest of the industry and with you guys. Our aim is that we can all improve the systems and to make it better, to avoid the mistakes that were done by the past. So one feedback that we have already would be regarding the urea management and particularly how to source it. It represents a challenge, especially for systems that cannot run without it, like Dennis was pointing out. Because it requires space, we need urea, we limit the size of the tanks on board, the urea tanks on board. So of course it will require to be filled up more regularly. Hans Martin, what are the urea to fuel ratio that are used when designing these systems?
At the moment at Diana, we have 2 ships under construction with the new system. And for those vessels, we use the manufacturer recommendations for the amount of urea. And this is approximately 3 to 4% of the total fuel capacity. You don't want to carry a lot more, as urea has a limited shelf life. So it's best to refill on a regular basis. And as you said, it's still a very hard, or it's a challenge to find places to refill, as it's such a new system.
Yeah, indeed. For our clients, urea is currently one of the biggest challenges related to IMO 3 after treatment system. Because it's very new, the industry, I believe, is not yet ready to deliver this product worldwide and quickly. We'll need more time, I'm sure, to get it properly organized and to answer the yachting demand. Urea is indeed difficult to source, even in main bunkering ports. Sometimes we must get the product delivered by container from hundreds, if not sometimes thousands of kilometers away, specifically for one vessel. Yeah. You can imagine how counter-efficient this can be currently in terms of global pollutant emissions. However, we are confident that it will be easier and easier with time, with more and more ships and yachts that are using SCRs. Of course, Fraser is currently talking with the main worldwide urea suppliers in order to maintain the best service to our clients and source that much more easily. Getting feedback on the SCR service units and maintenance requirements is also very new to us. Dennis, maybe can you tell us a bit more about maintenance and service, what's required?
Yes, of course. An SCR unit is a mechanical and electrical piece of equipment and therefore needs mandatory service on its wear and tear parts and on the filter cartridges. Depending on the use of the system and the service interval, this can differ per manufacturer. What we also see for new generation SCR units is that they can be equipped with remote access. This means the service engineer can log into the SCR system from his office to see what the problem is when the unit hits an alarm, or simply if a captain or chief engineer wants to know the state of the unit before making a crossing or having guests on board for a longer period of time. In this way, the crew can plan and schedule service on a time and date when it's convenient for them. I'm now talking all about equipment, but what I'm also very interested in is about the owner's point of view. Do they want to sail clean ships because of the environmental impact or just because regulations force them to do so?
In our office, we see that clients really like the idea of a clean ship, but that they're not always aware of the possibilities. And for a custom yacht, clients follow architect, management companies like Fraser and shipyards. And it's our common responsibility to inform them that these techniques are available. On the other hand, we need reliable systems before they can be integrated on a large scale. And shipbuilding is very traditional and clients do not want to be a guinea pig. So regulation is needed to force innovation, to my opinion.
Yes, it's a very good question indeed, and I think it's a bit of both. It's a bit regulation and owners. So, of course, Fraser, like its clients, is very much conscious about the environmental challenge that the world is facing. Especially air pollution is responsible for more than 4 million premature deaths in the world. So we are all convinced that that we need to do more for the environment, and we need more environmentally friendly yachts for sure. So furthermore, like Julian said in the beginning, Europe and IMO strategy to reduce the shipping greenhouse and pollutant gases emission is very ambitious. Anticipating the upcoming requirements and selecting the most efficient technology available is not only a need to minimize our impact on the environment, which is of course our main concern, but also it's very important if we want to protect our clients' investment on the long term. Indeed, we need to realize that innovation is going very fast. I think everybody is aware about that. Even the best systems today are likely to be obsolete in 10 years' time, and it's going to be superseded by technology that probably yet remains to be invented. So I'd like to see a vessel as a big puzzle, combining various technology. Each system of the yacht should be exchangeable when a better technology becomes reliable and available. With the Energy Efficiency Design Index and the Ship Energy Efficiency Management Plan, the regulations that are coming up soon, we are already driving the green transition. I think that not doing so would be leading to a very difficult and painful situation when this regulation will be applicable in the next few years. Julian, what is your opinion?
Yeah, thanks, Roman. I mean, from our side, I think what we're seeing is a real desire for decarbonisation in shipping and as well as in yachting specifically. Regulations are certainly serving to highlight the need and act as the initial driver, but I'm also seeing a real willingness and desire to achieve a reduction in current emissions from the owner's side.
Question from my side. What can we say about the economic advantages like reduction on port fees or other stimulators for cleaner ships?
I think perhaps I can answer that, Jeroen. I believe that the yachting industry could benefit from looking at what the merchant ship sector is currently doing with respect to industry initiatives to reduce emissions beyond the statutory minimum. Numerous industry-initiated greener shipping schemes currently exist, the Green Shipping Index, GHG emissions rating, and the Green Award, as well as several country-specific schemes, such as the Maritime Green Initiative implemented by Singapore. One example is the Environmental Ship Index, which was introduced in Europe in 2010 and provides a reduction in port dues or tonnage charges with below regulatory maximum SOx, NOx and CO2 emissions compared to the current emission criteria being set by IMO. The ships themselves are rated on a voluntary basis, free of charge, and eligible ships receive incremental discounts at participating ports. And from my side, I don't see any reason why the yachting sector couldn't adopt a similar approach across its major destinations, offering certain cost benefits for owners and operators who are prepared to go the extra mile to reduce their emissions and subsequent environmental impact. What about you, Roman? Could you tell us something about the experiences from the operator's side, please?
Yes, I think it's true that yachting is not always aware about such benefits and does not volunteer yet enough in the programs that you've mentioned. However, very positive things about yachts that are having low carbon footprint will be towards the charter business. That is very, very clear now. Quarter of our charter requests includes questions on the green credential of the targeted yacht. So that was very, very rarely mentioned up to now, just a year ago. So that's very new and that's very encouraging. So featuring the green technology and green actions on chartered yachts like ERC or wheels is becoming very important. Fraser is therefore encouraging owners to take any opportunity to embrace green initiatives. IMO 3 conversions in refit that we were talking about before is definitely one of these, and that will make a big difference and that's going to be having a high impact also for the vessel attractivity, especially for charter. So I'm sure that enthusiasm for this conversion will grow soon, And I believe that the upcoming decades will be mainly focused on improving green efficiency.
Excellent. Thanks, Roman. So in closing, what industry developments have we seen with respect to emerging green technology and alternative solutions to selective catalytic reduction and exhaust gas cleaning systems?
Yeah, I don't have any knowledge about alternatives to the SCR. Maybe somebody else can tell a bit more. What I see, of course, everybody is talking about alternative propulsion systems like hydrogen. I expect it will take some years before these systems will be available on a large scale, before they can be used for propulsion.
Sure. Yeah, well, I mean, the Cayman Islands Shipping Registry, we're really excited to be involved in the certification process for a number of cutting edge technologies. They include the FedShip OxyWatch system, which is a modular system that uses ozone generated on board to make NOx soluble water. We're also seeing the wider spread use of hybrid diesel electric systems, with the added bonus of single deck engine rooms in very large yachts, leading to additional luxury spaces on the lower deck. And also a move towards full electrification, which of course has its operational limitations. Whilst the inherent risks associated with lithium-ion batteries and the thermal runaway process may well prove the limiting factor in terms of their wider spread use, we're also involved with other projects which are investigating the use of alternative cell chemistry in order to eliminate such risks. Finally, we're seeing an increasing interest in the use of methanol and hydrogen fuel cells, which of course need acceptance in accordance with the IMO's provisions for alternative designs and arrangements. But my point is that all these things can and indeed are being done at the current time. So I think from that perspective, the future looks very exciting.
Yes, I definitely agree. And I believe that the future will be a combination of various technologies, not just one. And that will probably include electrical propulsion. Combining technology for me is the most reliable way to keep the yacht up to date with the environmental standards that are coming up, and to also satisfy and meet the challenge that the environment is giving us.
As hydrogen may need a lot of big volumes because of the low caloric values, in addition to diesel, I'm doubting if the diesel is not so bad at all.
Yeah. Okay, thanks, Jeroen. Yeah, but well, thank you very much, ladies and gentlemen. That brings today's webinar to a close. Once again, many thanks for joining us this afternoon. We deliberately wanted to keep it a little bit short, as we were aware that the webinar space is exceptionally busy at the current time. So thank you very much for your time. Hopefully you will have seen that whilst we as an industry are continuing to take significant steps to reduce our environmental impact, we still have some way to go in order to meet the IMO's objectives between now and 2050. Personally, I'm particularly encouraged to see the development of compact selective catalytic reduction systems, which will undoubtedly prove beneficial for vessels of all sizes. Finally, for those of you that would like a recap at any time, this webinar has been recorded and a copy will be sent to all of you who kindly registered for attendance this afternoon. So please feel free to circulate that as you see fit if you have any other colleagues that you feel may benefit from today's discussion. It will also be available on a number of our respective websites. Thank you very much, everybody. Stay safe, take care, and goodbye.
Bye-bye.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye-bye.